Let's take a look at what we're talking about when we say exponents. Now, most of you are familiar with the term exponents, but you might not know what the basic pieces are made up of. 2 to the power of 3 really has two numbers in it. The 2 is what we call the base, and the 3 is actually the exponent. It's the little number that's written up higher. Now, 2 to the power of 3 actually means that we're going to take 2 and multiply it 3 times. An exponent tells us how many times to multiply the base. So 2 to the power of 3 is really 2 times 2 times 2, or 8. What if it was a fraction, though? Let's take another example. What if we had 2/3 and all of that was raised to the power of 2? Well, there's two ways to think about this. 2/3 is really the same thing as, or 2/3 squared is really the same thing as 2/3 times 2/3. We can multiply numerators 2 times 2 and multiply denominators 3 times 3, and we come up with 4/9. Everything inside parentheses was squared. There's another way that it can be thought about, and usually this is a little bit easier in algebra, is we take each component of that fraction and we raise it to the power of 2. In other words, it's the same as saying 2 squared over 3 squared. As you can see, it's the same. It would work out to be the exact same number, because when we say 2 squared, well, 2 squared is 2 times 2, or 4. 3 squared is 3 times 3, or 9. And both of the answers are the same. Algebraically speaking, though, it's a little bit easier for us to do the second one. Now let's take some other examples and see what we mean when we say write something in exponential notation. Exponential notation tells us to use exponents. In other words, they don't want us to multiply all these numbers out. Example 1 is 5 times 5 times 5 times 5. The base is going to be 5. The exponent would be 4. In other words, it would be 5 raised to the power of 4. Let's look at example 2. We have 6's, and we have 1, 2, 3, 4, 5, 6, 7 6's. So our base is going to be 6. Our exponent is going to be 7. Exponential notation, 6 to the power of 7. Example 3 has 2 different numbers, so we'll have to have 2 different bases. In other words, we're going to have 4, and that's going to be squared. 2 4's, right? 4 times 4. And then we're going to multiply that times 3 3's. So we have 2 bases, 4 and 3. The 4 is multiplied twice, and the 3 is multiplied 3 times. So we would write that with 2 numbers and 2 different exponents. Example 4 has a 7, which is only written once, so we don't have to have an exponent. Anytime we have a number without an exponent, we understand that the exponent is 1. In other words, the base only gets multiplied 1 time. The 4 is we have 3 4's, so we'll say 4 times 4 times 4 is 4 to the power of 3, or 4 cubed. Now let's take a look at evaluating some of the answers. When we evaluate the answer, they actually want us to find out what the answer will be when we multiply. So let's look at example 5, and what we have is 6 squared, which is 6 times 6. If we evaluate that, we're going to multiply the 2 together, and our answer is 36. Example number 6, we're going to have to write 3 5 times. 3 times 3 times 3 times 3 times 3 times 3. Now, when I multiply 5 3's, I have to really think about it. I would probably multiply 3 times 3 and get 9, and then multiply 3 times 3 again and get 9, and then I'm going to multiply that 9 times 3. I'm just going to shortcut it. Then what I would do is say 9 times 9 is 81, and 81 times 3 will be my answer. It's not too hard for me to multiply. 3 times 1 is 3, and 3 times 8 is 24. 243. The biggest mistake we make when we use exponents, though, is looking and saying, I know it's multiplication, so my answer is 3 times 5, or 15. Well, 3 to the power of 5 is nowhere close to the number 15, as you can tell. So you just have to be careful about that. Number 7 is an exponent that doesn't really have to be written. 8 to the power of 1 is just 8. And number 8 is an easy one for us to figure out. 1 to the power of anything is just going to be the answer 1. We can multiply 1 as many times as we want to and still just come up with 1. Now I'd like to introduce you to the order of operations house at the bottom of the page. And the order of operations house is really something that I'm going to show you just to kind of keep in order which operation comes first? You've probably memorized, please excuse my dear Aunt Sally, and those are the initials that you find in the house, but please excuse my dear Aunt Sally does not take into account the fact that multiplication and division have to be done at the same time. In other words, the operation that we do first in multiplication and division is the one that we come to first in the problem. Addition and subtraction is the same way. So I put this in a house format, and the directions are very clear, and they're over to the left. You work it from the top to the bottom, left to right. In other words, if we start on the roof, we find in the roof we have parentheses. These parentheses mean that when you find parentheses in a problem, that's the first thing you do. Parentheses trumps everything, so we work those first. Second, we work our way down to the attic, exponents. After parentheses, we would look at all the exponents in the problem, and we would resolve those exponents. We would evaluate them and figure out what they were equal to. And then next, we come to the second floor. The second floor has multiplication and division, and they are together. This is where we work it left to right. In other words, we're going to pick the operation that comes first in the problem. If it's multiplication before division, we'd work multiplication first. But if division came before multiplication, we would work division first. They're on the same level of the house. Remember, they're on the second floor. Addition and subtraction is the final set of operations we do, and we also work those left to right. Whichever one comes first, that's the operation we work first.